This is Jacob's Algebra, Chapter 14, Lesson 1, Part 2. Okay, so we worked through number 4, which said to copy and complete the table by writing 1 over x to the first 5 decimal places in this second column, and then the exact answer in the last column. Now we're going to look at problem number 5. Problem number 5 is just like problem number 12 that I assigned for homework. It says, change each of the following rational numbers to decimal form. So for part A, we have 1 over 5 to the first power. Well, we know that's just 1 over 5. And 1 over 5 is 0.2. Okay, so for part B, we need to do 1 over 5 squared. 5 squared is 25, so that's 1/25, and that is 0.04. Part C is 1 over 5 cubed, which is 1 over 125, and that is 0.008. And then part D is 1 over 5 to the fourth, which is 1 over 625, and that is 0.0016. Okay, so parts E, F, and G ask questions about parts A, B, C, and D. It says, look at your results for parts A through D before answering the following questions about the decimal form of 1 over 5 to the n, where n is the power. Like we had 1 over 5 to the first power, n would equal 1 here, n would be 2, n equals 3, n equals 4. So we're doing the decimal form 1 over 5 to the n. That's the that's the fraction that we're looking at. And we converted all of those to decimals. So part E says, do you think 1 over 5 to the n, whatever your n value is going to be a decimal that terminates, or is it going to have repeating digits? Well, all of the ones that we did here, they all terminated. So I'm going to say that it's going to terminate or end, because it asks you if it ends or does it start repeating digits. So I'm going to say that it ends. Part F. What type of digit do you think is its last non-zero digit before the period? Before the period means before we start with the repeating zeros, because we could write zeros after this 2 that go on forever. We could write zeros after this 4 that go on forever. So it means right before it terminates, what type of digit do you think we're going to have? Well, what we have here is a 2, a 4, an 8, and a 6. So I would say that what we're going to end up with is an even number, because all of those are even numbers. Okay, part G. How many digits do you think it has before the period? Okay, so that means how many digits, how many decimal places do you think there are before it terminates? So let's see, 1 over 5 to the 1. When n equals 1, we have 1 decimal place. When n equals 2, we have 2 decimal places. When n equals 3, we have 3 decimal places. When n equals 4, we have 4 decimal places. So I'm going to say the number of digits before the period is going to be n. Whatever our n happens to be, that's how many digits we're going to have, how many decimal places we'll have. Then there's just a couple more parts. Part H says change these numbers to decimal form. So we have 1 over 5 to the fifth, and 1 over 5 to the fifth is 0.00032. And then part I is 1 over 5 to the sixth, and that one is 1 over 5 to the eighth. Sorry, not 1 over 5 to the sixth. And it's got 5 zeros, 1, 2, 3, 4, 5, and then 2, 5, 6. And these are problems. I'm sorry, I should have said this before. Problems number 4 and 5, the first 2 problems, actually the first 3 problems in set 3, you are expected to use a calculator for this. You are not expected to do all of this by hand. So then question part J says, do the results agree with your answers to parts E through G? So part E asked if you think it's going to end. Well, both of these end. Part F asked what kind of number do you think will be at the end? And we said even. Well, these are both even numbers, so that's true. And then question number G asked, how many digits are we going to have in our answer? And we have 5 digits here when it's 5 to the 5th. And we have 8 digits here where it's 5 to the 8th. So yeah, it is actually in whatever the power is that we raise 5 to, that's how many digits there are. So I'm going to say yes. So that was problem number 5. It is just like problem number 12 that I assigned for homework. You are expected to use a calculator for this, so please don't go and do all of this by hand. This is a calculator problem. Okay, so stop the video now and do problem number 12, then come back to see how the next one works. Okay, so now we're going to look at problem number 6. Again, this is a calculator problem. It says change each of the following rational numbers to decimal form. So for part A, we have 1/11. When we punch that into the calculator, what we get is 0.090909, and that keeps going forever. And so how we would write that is 0.09, and this 09 repeats. Okay, part B is 1/111. When you punch that into a calculator, we get 0.009009. I'm sorry, 009009. So, and that goes on forever. So we would write that as 0.009, and this 009 repeats. Part C is 1/1111. When you punch that into a calculator, you get 0.0009, 0009, and that continues on forever. So we can write that as 0.0009 repeating. Okay. Part D, well, it says look at your answers for parts A through C before answering the following questions about the decimal form of 1 over very large number. Let's see, we have 1, and then we have 3 1s, and then 3 1s, and then 3 1s, 1,000, million, billion, 1,111,111,111. So that's what we're going to be answering questions about. So for part D, it says, do you think this ends or do you think it has repeating digits? Well, since 1/11, 1/111, and 1/1111 all had repeating digits, I'm going to say that this repeats. Part E says, how many digits do you think are in its period? Well, when there were 2 1s, we had 2 digits in the period. When there were 3 1s, the period was 3. When there were 4 1s, the period was 4. Well, we have 3, 6, 9, 10 1s here. So I'm going to say that there are 10 digits in its period. And then question F says, what do you think is the last digit in its period? Well, all of the others ended with 9, so I'm going to say 9. And you can write the numbers 10 and 9 rather than writing out the words. So that was number 6. It's just like number 12 that I assigned for homework. Is that like number 12? Hold on, 11, 12. It's like number 13 that I assigned for homework, sorry. So you should stop now and do number 13 and then come back to the video to see how the next problem works. Okay, so now we're going to look at number 7. Number 7 is just like number 14. It says, write each of the following, ask the quotient of 2 integers in lowest terms. So basically, we're going to write these decimals as fractions. So we're just going to do 2 parts from number 7. Part B is 2.72. Now, to write this as a fraction, I'm going to move my decimal to the end, so that is 272. I had to move it 2 decimal places, so that means I put 2 zeros here. So I have 272 divided by 100. So what I need to do now is simplify. I'm going to divide the numerator and denominator each by 4. 272 divided by 4 is 68. 100 divided by 4 is 25. So that's going to give me the fraction 68/25. Okay, then I'm going to try part D. Part D is 0.4375. And so to work this, we're going to move the decimal to the end. That's 4 places, 4375, which means I write a 1 with 4 zeros because we moved the decimal 4 places. And now I need to simplify. So what I'm going to do is start off by dividing the numerator and the denominator both by 25, because I notice my numerator ends with 75, and that's a multiple of 25. So I divide 4,375 by 25, and I get 175. I divide 10,000 by 75, and I get 400. Well, now I have 175 over 400, and those are both multiples of 25. So 175 divided by 25 is 7. 400 divided by 25 is 16. So my answer is 7/16. The issue you're going to have on this problem is getting your answer in simplest terms. That's really going to be the only difficulty here. So this is number 7. It is just like number 14 that I assigned as homework. So stop the video now, do number 14, make sure you put your answer in simplest terms, and then come back and see how the next one works. Okay, so now we're going to look at number 8. Number 8 says use the method explained in this lesson to write each of the following as the quotient of 2 integers in lowest terms. What we're going to be doing now is changing repeating decimals into fractions. So for part B, we have 2.5. So I'm going to write x equals 2.5 with my 5 repeating. So that's really the same as 2.5555 going on forever. Now, since I have one decimal in my period, I have one decimal place, I'm going to multiply this by 10. 10 times this would be moving the decimal here. That would be 25.5 repeating. Now I can subtract. 10x minus x is 9x. 25.5 minus 2.5, my repeating 5 and repeating 5, those cancel. 5 minus 2 is 3. 2 minus nothing is 2. So 9x is equal to 23. So my x is 23/9. And since 23 is a prime number, we can't do anything else here. So 23/9 is how we write 2.5 repeating as a fraction. So now let's look at part D. Part D is 0.083, and just the 3 is repeating. So again, we have a period of 1. So we're going to let x be equal to 0.083. And then we're going to use 10x because we only have one, our period is 1, so we only need 1 0. We're going to move our decimal place over 1 for the 10x. So what we have here is 0.83, and then our 3 repeats. And we're going to subtract. 10x minus x is 9x. 0.83 going on forever minus 0.083. 3 minus 3, that's 0. 3 minus 8, we can't do that. We need to borrow. 13 minus 8 is 5, and we have a 7. So what we end up with is 9x equals 0.75. Okay, so that would mean that our x is equal to 0.75 over 9. Well, that's no good because we have a decimal inside of our fraction and we don't want that. So if I multiply the numerator and the denominator both by 100, then I will have 75 over 900, and that's allowable. We can divide, we just need to get rid of our decimal. So now if we divide the numerator and the denominator both by 25, 75 divided by 25 is 3. 900 divided by 25 is 36. Then we have 3/36. Those are both multiples of 3. So if I divide the 3 by 3, I get 1. Divide 36 by 3, I get 12. So my answer is going to be 1/12. We'll finish number 8. We'll do one more part in the part 3 video. And at that point, you will need to go do